Hello and thank you for joining me. Welcome to the first session of AZ-900 Microsoft Azure Fundamentals. I'm Alexandra Zakharova, Senior Technical Trainer and AI Course Lead at Microsoft, and I'm delighted to be your instructor for this course. The AZ-900 Azure Fundamentals exam is a great opportunity to demonstrate your understanding of essential cloud concepts, Azure services, workloads, security and privacy in Azure, as well as pricing and support options. I want to emphasize that this is a foundational course, so our main goal is to introduce you to these concepts and help you build confidence in the basics. In this first session, we'll start by exploring the fundamentals of cloud computing. You will learn what the cloud is, why organizations are adopting it, and the benefits it offers, such as scalability, reliability, and cost optimization. We'll discuss the different cloud models, private, public, and hybrid, and the shared responsibility model that defines role for security and compliance. Finally, we will look at core Azure concepts like regions, availability zones, and resource groups, which forms the foundation for everything you do in Azure. So let's get started and begin building your foundation in Azure. In our first session, we'll describe the core principles of cloud technology. Specifically, in our first lesson, we'll cover cloud computing, the shared responsibility model and concept, cloud models, capital expenditures, and operational expenditures. In the second lesson, we'll discuss the benefits of cloud technology and conclude the session with a description of various cloud services. If this is your first encounter with the cloud, don't worry, it's going to be great. We'll cover the general terminology of cloud computing using common terms used by various cloud service providers in the market. Now, let's get started and move to the most crucial part, defining cloud computing and its purpose. Nowadays, almost everyone uses cloud technology. When I say everyone, I mean restaurants, medical centers, employees, banks, logistics workers, HR, hairdresser, and so on. Basically, anyone dealing with programs or services over the internet. Even my grandmother recently asked me what I do at Microsoft, and when I told her that I teach cloud technology, to my surprise, she said she knows what cloud is. I asked her to explain, and she said it's where she stores all her pictures and photos. So what exactly is cloud computing? Cloud computing is the delivery of computing services over the internet, enabling faster innovation, flexible resource allocation, and cost efficiency. When you leverage the cloud, you essentially rent infrastructure from a cloud provider, including compute, networking, and storage resources. To better understand these components, let's draw a parallel with the functioning of a human body. Computing can be compared to the brain. It's the central processing unit where all operations take place. Networking, on the other hand, can be linked to the circulatory system, responsible for the flow of information and communication, similar to our limbs that facilitate movement. Lastly, storage can be seen as a warehouse or a library, acting as a repository for storing and retaining data and information, much like how our stomach digests and holds nourishment. These resources are hosted in data centers located worldwide, operated by third-party organizations. As a customer, you have access to leverage these tools and capabilities. Gone are the days when owning your own data center was the only option. The cloud provides flexibility and accessibility. It caters to businesses of all sizes, not just large corporations. The cloud offers multiple benefits, including financial advantages and reduced maintenance overhead. By utilizing a cloud provider, you can focus on your core business objectives instead of dealing with the complexities and costs associated with maintaining your own data center. Let's deep dive the different models of cloud computing. What are cloud models? The cloud models define the deployment type of cloud resources. The three main cloud models are private, public, and hybrid. Let's explore first the private cloud. It refers to a single organization having complete control over its infrastructure. This means they are responsible for all the hardware. Only that organization has access to the services and resources provided. As the saying goes, with greater power comes great responsibility. And this holds true in the case of the private cloud. While you have control over your data and can determine who accesses it and how, you also have the burden of high overhead costs. Additionally, technical expertise is required to handle tasks such as ordering, setting up, and maintaining the infrastructure. In the private cloud, you are accountable for fixing any issues that arise, as there is no panic button to rely on. Despite the challenges, there are benefits to the private cloud. For instance, you don't need a public connection to access your data. You can establish a completely private network for accessing your resources. As the owner of a private cloud, you maintain control over all aspects, from determining who has access to your data to deciding how it is managed. However, it's important to remember that with this control comes the responsibility to address any problems that arise. If you make a comparison, the private cloud can be likened to owning your own car. You have the freedom to manage it according to your needs and preferences. However, it's important to note that owning a car requires maintenance and can be more expensive than using public transportation. Now, many people may think that private and public clouds are complete opposites. However, the truth is that they share many design principles and technologies. Let's delve into the details. A public cloud is like a bus or subway system. It is built, controlled, and maintained by a third-party cloud provider, allowing anyone who wants to purchase cloud services to access and use its resources. Just like public transportation, the public cloud is open to everyone. Users can easily hop on and hop off whenever they need, paying for the distance they travel based on their specific stops. One of the main advantages of the public cloud is that users are not responsible for its maintenance. They can simply utilize the services without worrying about infrastructure management or hardware upkeep. It's similar to how passengers on a bus or subway don't worry about maintaining the vehicle or the tracks. Another parallel between the public cloud and public transportation is the ease of access. No significant license are required to use the public cloud. Similarly, when boarding a bus, you don't need a specific license to do so. The public cloud allows individuals and organizations to quickly leverage its resources and services without extensive setup requirements. Just as you pay for public transportation based on where you boarded and where you go out, the public cloud operates on a pay-as-you-go model. Users are charged based on their usage, whether it's the amount of storage used, computing resources consumed, or data transferred. So, when thinking about the public cloud, envision a convenient and accessible system, much like taking a bus or subway. It offers flexibility, scalability, and cost-effectiveness for users, enabling them to leverage cloud resources without the burden of infrastructure management or complex requirements. Now, let's discuss a hybrid cloud, which combines the best of both worlds. Think of it as having the option to choose between a bus and a car depending on your needs. The hybrid cloud allows organizations to leverage components of the public cloud while maintaining control in the private cloud. For instance, let's consider an accounting firm or a medical office that needs a public-facing website. They can utilize the public cloud to host their servers for the website, ensuring speed and accessibility. At the same time, they can connect that website to a secure database in their private cloud to comply with data governance regulations. The hybrid cloud offers flexibility tailored to different organizational needs and preferences. Keep in mind that every organization has unique requirements, and the hybrid cloud provides solutions that are flexible like no other option out there. If we return to our analogy, considering that I live close to Paris, there is often significant traffic in the city center during the morning. Given that I live outside the city, I have the option to drive to the train station and then utilize public transportation to reach the city center. This involves a combination of two approaches, using a private car and relying on a public transportation. As we continue our journey today, we'll explore different terms and scenarios where one cloud model may be more beneficial than the other. In the table you see on my screen, several key aspects of comparing different cloud models are presented. Public cloud saves us money as we only pay for what we use. All programs and applications are installed quickly. In the private cloud, everything is much more expensive from the beginning because we must buy our own equipment, ensure its security, and not forget about maintenance and updating our applications. Finally, the hybrid cloud provides flexibility as it allows us to decide where to run applications and how to control security. To remember these three terms for the exam, you can use our analogy with different models of transportation. Now, turning our attention to cloud models, we have covered a lot of ground. However, a pressing question arises. Alexandra, how does the payment structure work? And this is where the cloud truly shines as an outstanding solution. When we delve into cloud expenses, we can approach it from two distinct angles. To illustrate, let's consider a scenario. Imagine my online business involves selling flowers. I'm looking to quick start a website and I'm considering local hosting. In the context of a private cloud model, getting started would entail an upfront investment. And I would have to acquire a server rack, cables, wires, and all the essentials to launch. This initial investment can be substantial. However, over time, assuming my demand remains relatively steady, my physical infrastructure cost will taper off. While the upfront expenses might be significant, it's important to remember that this isn't a recurring monthly cost. The assets are now under my ownership. On the flip side, if my business expands and scaling becomes necessary, I will need to invest further. What I have just described is known as capital expenditure or CapEx model. In this model, you front-load your expenses, creating a financial burden. While it's true that you won't encounter additional charges since you have paid it all upfront, you're exposed to the risk of depreciation and obsolescence. Similar to purchasing a laptop today only for it to be outdated next year or buying a brand new car that loses value once it leaves the lot. Technology follows a similar trajectory. In contrast, OpEx is spending money on services or products over time. Running a convention center, leasing a company car, or signing up for cloud services are all examples of OpEx. It operates on the lines of operational expenditures. This approach holds immense value, as it supports a pay-as-you-go philosophy. You get what you need right away and are billed only for the products and services you actively utilize. Cloud computing falls under OPEX because cloud computing operates on a consumption-based model. With cloud computing, you don't pay for the physical infrastructure, the electricity, the security, or anything else associated with maintaining a data center. Instead, you pay for the IT resources you use. If you don't use any IT resource this month, you don't pay for any IT resource. Now, let's move on to the various advantages of the cloud. When deploying applications, services, or any IT resource, it's essential that these resources are available when needed. High availability is designed to ensure maximum accessibility regardless of possible failure or other events. When developing a solution, it's crucial to consider the service availability guarantees. Azure provides a highly available cloud environment, which uptime guarantees based on the specific service. These guarantees are part of the Service Level Agreement, SLAs. Another significant advantage of cloud computing is the scalability and elasticity of cloud resources. Scalability allows you to adjust resources to meet demand. When sudden traffic spikes and system overload occur, scalability enables the addition of extra resources to efficiently handle the growing demand. Elasticity, on the other hand, allows for automatic scaling. Scalability generally comes in two forms: vertical and horizontal. Vertical scaling involves increasing or decreasing resource capabilities. Horizontal scaling involves adding or removing resources. To explain simply, think a virtual machine. Let's say I have a virtual machine and it currently has 4 gigabytes of RAM. Based on analytics embedding in Azure, my manager tells me, Alexandra, 4 gigabytes are not enough for our current needs. We need to increase its size. So what do? Well, I scale this machine up to 12 gigabytes of RAM. But guess what? New analytics reports come in and my manager says, Alexandra, you went too far. 12 gigabytes are too much. We can save money if we scale down to 8 gigabytes. And that's a perfect number for our virtual work environment. So I scale it down to 8 gigabytes. Regarding horizontal scaling, let's say for the task I need to perform, one virtual machine isn't enough. I need to have multiple virtual machines running simultaneously. So I will scale to 2 or 3 virtual machines. It's important to know that I'm using virtual machine memory as an example, but you can scale any other resource in a similar manner. As you remember, I have already mentioned that elasticity is the ability to automatically scale your resources. Let's say you have a website for selling children's toys, and you can use automatic scaling to add more storage automatically during holidays period. Similarly, in the event of significant decrease in demand, deployed resources can be scaled down automatically. Let's get back to our advantages. Reliability is the ability to recover a system after failures and to continue operations. It's also a fundamental principle of well-designed platform. Cloud, with its decentralized structure, naturally supports a reliable and robust infrastructure. Thanks to this decentralized structure, cloud allows resources to be deployed across regions worldwide. With such a global scale, even if one region experiences catastrophic events, other regions continue to operate without disruption. You can design application to automatically leverage this enhanced reliability. In some cases, the cloud environment itself will be automatically moved to another region without any action required from your side. In this training, we'll further discuss how Azure utilizes global scaling to ensure reliability. The next advantage of the cloud is predictability. Predictability in the cloud enables you to confidently move forward. Predictability is mainly focused on forecasting performance or costs. Performance predictability involves forecasting the resource needed to ensure the most efficient conditions for customers' operations. Automatic scaling, load balancing, and high availability are just some of the cloud concepts that ensures performance predictability. If you suddenly need additional resources, elasticity allows you to deploy additional resources to meet demand, and then scale down when demand decreases. Or if traffic is heavily focused on one area, load balancing allows redirecting some overload to less burdened areas. Cost predictability is about forecasting cloud expenses. Through the cloud, you can track resource usage in real time, monitor resources to ensure their most efficient utilization, and apply data analytics to identify patterns and trends that help better plan resource deployment. The sixth characteristic of the cloud is security. Cloud offers robust security measures, including data encryption, identity, and access management, and continuous threat monitoring. Leveraging the cloud allows organizations to tap into the expertise and resources of established providers, enhancing their ability to fend off cyber threats and adhere to industry compliance standards. Azure's advanced security features, regular updates, and dedicated security teams help safeguard sensitive data and applications, providing businesses with a strong foundation to migrate and to mitigate risk and maintain a secure online environment. The seventh advantage is about features supporting governance and compliance requirements. Cloud capabilities such as predefined templates guarantee that all deployed resources adhere to corporate standards and governmental regulations. Additionally, you can update all deployed resources according to new standards as they arise. Depending on your operational models, software patches and updates can also be applied automatically, simplifying management and ensuring security. And finally, the eighth advantage of cloud computing is manageability. Cloud management means managing cloud resources. In the cloud, you can perform various actions such as deploying resources based on pre-configured templates, eliminating the need for manual setup. Tracking resource health and automatically replacing faulty resources, as well as receiving automatic alerts based on configured metrics to monitor real-time performance. Moreover, the cloud offers various management methods that we will discuss shortly. Now, let's explore the different types of cloud services and describe some of use cases and benefits associated with each service. Infrastructure as a service, IaaS, is the most flexible category of cloud services as it provides maximum control over cloud resources. In the IaaS model, the cloud service provider takes care of maintaining the hardware, network connectivity to the internet, and physical security. You're responsible for everything else, including installing, configuring, and maintaining the operating system. Network settings, databases, storage, and more. With IaaS, you essentially rent the equipment in the cloud data center, but have the full control over how to use that equipment. Platform as a service, or PaaS, is a comprehensive cloud development and deployment environment with resources that enables the delivery of a wide range of cloud applications, from simple to sophisticated solutions. Similar to IaaS, PaaS includes infrastructure, servers, storage, and networking equipment, as well as the middleware, development tools, business analytics, database management services, and more. PaaS is designed to support the entire life cycle of a web application: development, testing, deployment, management, and updates. In PaaS scenario, you don't need to worry about licensing or installing patches for operating systems and databases. PaaS is a great choice for providing a fully functional development environment without the need to manage all the development infrastructure. Software as a Service, or SaaS, is the most complete cloud service model. From a product perspective, with SaaS, you essentially rent or use a fully developed application. Common examples of SaaS implementations include email services, financial management software, messaging applications, and connectivity software. While the SaaS model may be least flexible, it also offers the easiest way to get started. It requires minimal technical knowledge or experience for full utilization. The shared responsibility model applies to all types of cloud services. The diagram you see on the screen illustrates different levels of responsibility depending on whether you use cloud services like IaaS, PaaS, and SaaS, or manage your own on-premises data center. Let's start with the right side of the diagram, which represents your on-premises network. Here you are entirely responsible for everything, starting from the physical infrastructure. You are also responsible for your operating systems, applications, managing all your users, and ultimately your data. However, as you transition to the cloud, the responsibility is shared between you and your cloud provider. In the IaaS level, you rely on Microsoft for supporting the physical infrastructure. We also take responsibility for its security, but you are responsible for everything that is not part of this physical infrastructure. When you move to Platform as a Service PaaS, you no longer need to worry about the underlying operating system. Microsoft takes care of securing the operating system and some other management elements such as networking and application support, but you still need to contribute. This includes securing your applications and managing those who have access to your data. SaaS, software as a service, is a model where the cloud service provider takes the highest responsibility and the user has a minimal responsibility. In SaaS environment, you are responsible for the data you add to the system, the devices you allow to connect to the system, and the users you grant access. Practically everything else falls under the cloud service provider's responsibility. They're responsible for the physical security of data centers, power, network connectivity, application development, and software updates. What I want you to take away from this table for your understanding is that your level of responsibility will vary depending on whether you use cloud services or set up equipment on premises. Additionally, you always take responsibility for your users' devices and data. Now, let's find an analogy from real life and talk about pizza. Yes, pizza. Our on-premises system is like making pizza at home, where you are responsible for all the ingredients, the table, cooking, and etc. Yes, it's like ordering groceries to your house to make the pizza. PaaS is like pizza delivery, where we receive the pizza in a box at home, but we still need to set the table, get drinks, and clean up. And SaaS is like going to a pizza restaurant where the tables is ready set, food and drinks are ready, and they're even clean up after us. I hope this delicious analogy helps you better remember the shared responsibility model. Let's delve into a comparison of these three distinct cloud service types. Infrastructure as a service, yes, is like renting computer equipment from the cloud. You get to control how you use it, such as setting up different virtual machines for various tasks. Platform as a service PaaS, on the other hand, often finds application in software development. Here, the cloud service provider takes charge of platform management. For instance, you might utilize PaaS to build a web application without needing to worry about underlying infrastructure. Moving to software as a service SaaS, this entails receiving a fully functional application ready for use. Think of it like accessing an email service or a collaborational tool such as Outlook, Salesforce, or MailChimp, where users pay based on a subscription model for the software they utilize. Now, let's recap what we have covered in this session. We began by defining cloud computing and exploring the different cloud deployment models, comparing private, public, and hybrid clouds to familiar transportation options to make the concept easier to understand. Next, we discussed the difference between capital expenditure, CapEx, and operational expenditure, OpEx, highlighting that cloud technologies primarily leverage operational expenses for flexibility and scalability. We then examined the 8 key advantages of the cloud, including cost efficiency, high availability, and global reach. After that, we explored the different types of cloud services, yes, PaaS and SaaS, and used the pizza analogy to illustrate how responsibilities shift depending on the service model. With that, our first session comes to an end. Your learning journey doesn't stop here. There are many ways to continue building your skills. I encourage you to watch the other videos in this course or explore your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for joining me and happy learning!